Hi everybody, in this video I am going to discuss booth algorithm for multiplication of two integer numbers. The subject is computer architecture. It is one of the important topics for semester examination. Let us consider the booth algorithm step by step. Let us consider two number minus 9 into minus 13. So one of them is multiplicand and another is multiplier. Multiplicand is stored in beer equal to minus 9 and keyword is quotient register, that is multiplier equal to minus 13. Now we need to convert it equivalent binary. 9 mean 1248, that is equal to 1001, and we need to extra add 1 bit, that is to make the register as 5-bit register. Now keyword is equivalent 841, that's mean 184 and 101, that's mean 1101 and add 0. When the numbers are negative, we need to perform 2's complement. If the number is positive, so that is BR will be the equivalent binary number. But as both are negative, so first of all we need to perform 1's complement of this number. 1's complement equal to 10110, and 2's complement will add 1 10111. 2's complement equal to 1's complement plus 1. Now the 1's complement, as it is negative number, that is 10010, and add 1, that is 10011. Now these are the final values of beer and keyword. Now AC is accumulator, that is equal to number of bits. How many bits are there? 5 bits. So it will store 50. And sequence counter is 5, that's equal to binary is 101. Now we need to perform some operation like beer bar plus 1. Beer bar plus 1, just mean beer bar is this one, mean 10111 bar plus 1, that's equal to 01000 plus 1, that's equal to beer bar plus 1, 01000 plus 1. So this is the initial stage of booth algorithm. If one of them is positive, then no need to perform 2's complement. If both are negative, then we will perform 2's complement of both the number. If both are positive, then no need to perform 2's complement. That means positive mean we will consider the binary number, and 2's complement negative mean we need to perform 2's complement. This is the basic concept. Now initially we need to construct a table, that is Qn plus 1, Qn plus 1 AC accumulator, keyword is quotient register, and then again Qn plus 1, then sequence counter, and finally calculation part is there. Now Qn plus 1 is initially 0 according to booth algorithm, and AC is initially number of bit, that is 5 bit 0, and keyword is there 10011. Qn plus 1 is 0, SC means sequence counter, this is sequence counter, that's 101, and Qn is the least significant bit. This is one is known as least significant bit, and this one is known as most significant bit. Least significant bit of keyword, that is 1. Here it is 1. Now this is the initial stage. We need to remember this table to perform booth algorithm. First of all is 00 for 00, that's mean only arithmetic shift right operation. 01 AC will be the AC plus BR, then arithmetic shift right. For 10 AC equal to AC plus BR bar plus 1, then arithmetic shift right, and for 11 only arithmetic shift right. So this is the main structure for booth algorithm. 00 only arithmetic shift right, 01 AC plus BR, then arithmetic shift right, 10 AC plus BR bar plus 1, then arithmetic shift right, and for 11 only arithmetic shift right. Now it is 10, that's mean AC plus BR bar plus 1. First of all write this one again, 1001101. Here it is 10, so AC new AC will be AC plus BR bar plus 1. That is AC is initially 00000. BR bar plus 1 is there, 01001. Now new AC is 10010. That means 01001, and keyword will be same. Now we need to perform arithmetic shift right. Arithmetic shift right means left to right. 0 is there, 0 1 0 0, and 1 is transferred here. 1 0 0 1 and 1. Now sequence counter will be reduced to 4 to 3, 1 0. The equivalent binary is 1 0 0. Now this is the first step. Now here Qn is again 1 and Qn plus 1 is also 1. Both are 1 1. Write this again. Now as it is 1 1, or only arithmetic shift operation is there. 0 0 0 1 0 0 1 1 0 0 1 and reduced to 3 to 2 0 1 1. Only arithmetic shift right operation is there. No need to perform others operation. Now as Qn is 0 and Qn plus 1 is 1. Now it is 0 1 0 0 0 1 0 0 1 1 0 0 1 0 0 0 1 1. As it is 0 1 mean only AC will be AC plus BR. That is AC is 0 0 0 1 0. BR mean also this one is BR 1 0 1 1 1. So that means 1 1 1 0 1 1 0 1 1. This one is the new AC. This means 1 1 0 0 1. And keyword is remain same 0 1 1 0 0. Now we need to perform arithmetic shift right. That's 1 1 1 0 0 1 0 1 1 0. Then transfer to 0. Now see sequence counter will be 1 2. Now it is Qn is 0, Qn is 0 and Qn plus 1 is also 0. 0 0 mean only arithmetic shift right operation will be there. Or only arithmetic shift right mean 1 then 1 then 1 1 0 0 1 0 1 1 and 0. Here Qn is 1 and sequence counter operation sequence counter is 0 0 1 and there is only one step is remaining. Let's see here Qn is 1 and Qn plus 1 is 0. And this is the only arithmetic shift right. In case of AC plus BR plus 1, arithmetic shift right also is there, arithmetic shift right operation is also there. But for 0 0 and 1 1 only arithmetic shift right. Now the last step, that's mean for 1 0. For 1 0, write this again. 1, this one is 1 and 0, 1 1 1 1 0. 0 1 0 1 1 0 0 0 1 and calculation. Here it is 1 0. That means AC new AC will be AC plus BR bar plus 1. AC is new AC is 1 1 1 1 0 and BR plus 1 is 0 1 0 0 1. Add this number, that is 1 1 1 0. There is a carry and there is extra bit and we need to discard this bit. So new AC is 0 0 1 1 1 and QR remains same. Now we need to perform a shift right operation, that is arithmetic shift right is here for AC and QR. Here shifting operation is 0 0 is transferred, 0 is transferred 1 1 1 0 1 0 1 and last one is transferred to Qn plus 1 and sequence counter is 0 0. Now the Booth algorithm will stop here. Because when sequence counter is reduced to 0 0 0, we need to stop the Booth algorithm. Final answer is AC and keyword. Answer is AC and keyword. That is equal to 0 0 0 1 1 1 0 1 0 1 1 0 1 0 1. If any one of the number is negative and one of them is positive, then we need to perform 2's complement of that final answer also. But here both number is negative. So this is the final answer. Suppose 9 is negative, minus 13 is negative, then we need to perform 2's complement of this final answer. But here both are positive. Remember this, both are positive. So this is the final answer. Now convert it equivalent to decimal number 1, 2, 4, 8, 16, 32, 64. That means 64 plus 32 plus 16 plus 4 plus 1. That is 6, 6, 12 and 5, 7, 9, 10 and 1, 1, 7. This is the final answer. Check it whether it is correct or not. Minus 9 into minus 13, that is equal to 7 and 27 and 9, 11, 1 and 1, 7. This is the right answer. So this is the concept of booth algorithm. It is one of the important question for computer science and engineering related topics. It is important for BTech, BCA, MCA or diploma students. So thank you very much for watching this video. Share and subscribe to the channel. Thank you.